The same substance, at the same dose, can produce dramatically different consequences for a developing fetus depending entirely on the specific week of pregnancy during which exposure occurs. A principle that reveals prenatal development as a tightly sequenced, remarkably time-sensitive process where specific organs and systems are vulnerable only during narrow, specific developmental windows. The germinal stage, spanning approximately the first 2 weeks following conception, begins with the fertilized egg, or zygote, undergoing rapid cell division as it travels down the fallopian tube toward the uterus, eventually forming a structure called a blastocyst that implants into the uterine wall, establishing the physical connection to the mother's body that will support all subsequent development. A substantial proportion of fertilized eggs, estimated at around 50% by some research, fail to successfully implant or survive this earliest stage, often before pregnancy is even clinically detected. The embryonic stage, spanning roughly weeks 3 through 8 of pregnancy, is the period during which all major organ systems and body structures, including the heart, neural tube, limbs, and facial features, initially form through a process called organogenesis, making this stage by far the period of greatest vulnerability to teratogens, substances, or exposures capable of causing developmental abnormalities, since a disruption during the specific narrow window when a particular organ is actively forming can produce lasting structural abnormalities in that organ. The fetal stage, spanning from roughly the 9th week of pregnancy until birth, involves continued substantial growth in size along with progressive refinement and functional maturation of organ systems and structures already established during the earlier embryonic stage, including ongoing brain development that continues at a rapid pace throughout this stage and, notably, continues well beyond birth into early childhood, meaning the fetal stage, while generally less vulnerable to major structural malformation than the embryonic stage, remains highly vulnerable to teratogens affecting brain development and organ system function specifically. The critical period principle in teratology holds that the specific developmental consequence of exposure to a given teratogen depends heavily and specifically on the precise timing of exposure relative to each organ system's own individual critical formation window, meaning the exact same teratogen exposure can produce dramatically different effects or no detectable effect at all, depending on whether exposure occurs during, before, or after a specific organ's particular critical period. For instance, thalidomide exposure caused severe limb malformations only when it occurred during the narrow window of limb formation, roughly days 20 to 36 of pregnancy. Fetal alcohol spectrum disorders result from maternal alcohol consumption during pregnancy, representing one of the most common entirely preventable causes of intellectual disability in developed countries, with effects ranging from subtle cognitive and behavioral difficulties to the more severe fetal alcohol syndrome, characterized by distinctive facial features, growth deficiency, and significant intellectual impairment, reflecting alcohol's teratogenic effects on the developing brain across essentially the entire span of pregnancy, since no established safe threshold or safe timing window for alcohol consumption during pregnancy has been scientifically identified. Beyond alcohol, several other well-documented teratogen categories pose significant risk during pregnancy, including certain maternal infections, such as rubella and Zika virus, which can cause severe developmental abnormalities, particularly when maternal infection occurs during the vulnerable early embryonic period. Specific medications, including some anti-seizure drugs and the acne medication isotretinoin, which carry well-established teratogenic risk profiles requiring careful medical management during pregnancy, and environmental toxin exposures, including lead, which can impair fetal neurological development even at exposure levels not clearly harmful to adults. Prenatal development unfolds as a precisely sequenced, remarkably time-sensitive process, in which the specific consequences of any teratogen exposure depend critically on exactly when during pregnancy that exposure occurs. Understanding critical periods explains both why prenatal care and avoiding known teratogens matter throughout pregnancy, and why the timing of any specific exposure matters as much as the exposure itself.